All right, so now that we've seen classes and objects in action and we've used them a little bit, it's time to do a deep dive and understand exactly how classes and objects work in Dart. So firstly, a class is simply just a blueprint, and it's used to create all of the things that we're going to be showing in our app and the user is going to be interacting with. So essentially everything that makes up our app is going to be created using a blueprint that's called a class. Now, what exactly is an object then? Well, when we take that blueprint and we take it to the factory and the actual car in this instance gets built, well, that's the object. That's the actual thing that's going to be doing the driving, or in our case of an app, it'll be the actual button that can receive taps and the images that actually change. Those are the actual objects. But because we can't see the objects until the app is running, we have to plan out how they will function and how they will work by creating these classes. A class has two really important things. One are its properties. So if we're building out a car, then that will be its color, or the number of seats it has, or the number of wheels it has, or the number of doors it has, or all sorts of things that are things to do with the characteristics of the object. And in Dart, these things that we've been referring to as variables, when they're inside a class, they're now called properties or fields. Now, the other important part of a class that we need to define are its methods. So the things that it can do, the actions that the object that will eventually get created will be able to perform. In the case of our car object, that might be to drive or to brake or to turn around. And these methods are actions that the object will be able to do that we're going to define in the blueprint even before the object gets built. So, for example, you might see a class defined like this. Firstly, you have that class keyword, which shows that everything else that's coming afterwards is going to be a blueprint. And then you have the name of the class. So in this case, we're building a car blueprint. And by convention in Dart, as with many other languages, when you're creating a variable, say here we've got number of doors, or when you're creating a function, say here we've got drive, those are all camel case starting with a lowercase word. But when you're creating a class to show that it's different, we always start off with a capital letter. So all the words in your class names are capitalized. Now, here's our car class, and inside these curly braces are the definitions for this car class. So this is the blueprint of exactly how our car will look and also how it will behave. And between the looks and the behavior, we end up with a class. So in this case, we have just a single property, which is called number of doors, and this defines a characteristic of the car. Namely, how many doors it has. This car has 5. This car also has a function called drive, and this defines a little bit of functionality for the car. So, namely, this car, when we call this thing called drive, is going to start turning the wheels, for example. Now, notice how inside a class, our variables are no longer called variables, and they're called properties or fields. Similarly, a function, when it's defined inside the curly braces of a class, it's now called a method and not a function anymore. So if you're new to programming, there's a lot of new words, and it's a good idea to build your own glossary of words, because it's just like learning a new language. When people refer to a method, you can think of them as just a function that's associated with a class. And when people are talking about a property, it's simply a variable that's associated with a class. And once you hear it often enough, then it'll start becoming second nature. Now, once we have our object, it's the object that actually performs those pre-planned actions in the class, such as moving, right? Or it actually has those characteristics which we defined in our class, such as its color property or the number of doors property. The two parts of creating a object are, first, we have to create the class. And this is going to be the blueprint that's going to define everything about the eventual object that will get created. So we use the class keyword, we give the class a capitalized name, and we define variables in it, which are properties for that class. And we also give it functions, which become the methods that the class can do. And when we actually create the object from this class, then our code looks something like this. We would define the type, which is in this case the name of the class, and then we would give our object a name, and finally we would set it to equal a new version of that class. When we have the word car and these empty parentheses, it's basically creating a new object from this blueprint. It's like sending that blueprint to a factory and out comes our actual car object. Now, this is all very abstract and we're having to imagine a lot of it in our head. So let's put it down onto code and head over to our trusty dartpad to be able to see this in action and understand it a little bit better. So I've got my empty main method up here, and I'm going to create a new class right below it. I'm going to call that class human. So remember, it should be capitalized. And this class of humans are going to have some properties, so some characteristics. So what kind of characteristics might a human have? Well, they might have a height, right? We could create a height property, and maybe it'll have an age property. And when we create a new class, we can either create these properties as empty or null, such as here, or we can say that by default, when we create a new human, it should always have a height. Let's say that when a default human gets created, it starts out being, I don't know, maybe 15 centimeters in height. And maybe it will have a default age of 0. So now if I go into my main method and I create a new object from this human, let's say that we create a new human. So that's going to be the type of this object. And our actual human, let's call her Jenny, is going to be created using our human class. And we do that, of course, by writing human, and then we have a set of empty parentheses. And this builds out our new human. So human is the blueprint for all humans. They all should have a height and they all should have an age. And we have some default values for how humans should be when they first get built. And Jenny is our actual object who's built from this blueprint. And when we're doing things in our program, we're actually interacting with Jenny rather than the sort of abstract blueprint kind of for a human. So we might say something such as, let's print Jenny's height. So we have our print statement, and then we're going to tap into our Jenny object, and then we're going to use the dot notation to tap into its property, namely the height property. So we'll say Jenny.height, and let's print that into the console. And you can see that because we've given all humans a default starting height of 15, Jenny also has a height of 15. Now, a little bit later on, I could maybe change that. Maybe Jenny grows a bit, and let's say that her height is now 20. So I can change all of these properties, and I can tap into them simply by using that dot notation, by saying that this is the object that I'm concerned about, and it finds the object, which we know gets created from the human class. And by default, all of the properties of a human start out with these values. Then I'm saying, get me Jenny's height. And that's what that dot says. It's just saying, this is the property associated with Jenny that I want to know about. Or later on, when our human gets some functions associated with it, you'll see that the way that we tap into it is still with the dot notation. So when you see something dot something, it usually means that this is an object and we're tapping into one of its properties or methods. Now, at the moment, every single new human that we create starts out with a height of 15. Now, that might not be true, right? So let's say that we created another human, and this is James, and he's also created from the human class, which is what this part means. We're going to the human factory and we're building a new human. And if I was to print his height, you'll see that it's exactly the same. He's also 15 centimeters tall. But that's probably not really true, right? Why should it be that when a new human gets created, they all have the same default height? What if we wanted to initialize each object with a different value for some of these properties? How would we do that? Well, we already saw that in the last lesson, that we can use something called a constructor for our class. And to create a constructor, we would write the name of the class, so it's human, and then we would create a set of empty parentheses. And just as when we create a function, we provide some inputs into these parentheses, when we create a constructor for a class, we can provide some inputs to our class. So we could say that maybe the starting height property, which is going to be a double because our height property is a double, we'll give it a name of starting height. And now inside the curly braces, we can assign the starting height to the height. And height can start out without a value. It'll start out being null. But when we create our new human, we have to provide a starting height. And then we can say that the human's height property will be set to whatever the starting height is that we provided. So now we get some errors here because it needs a starting height and we haven't given it one. So let's add that in. So we could say that Jenny is a human who starts out being 15 centimeters. But James starts out being a human who is, maybe he's a bit taller, maybe he's 20 centimeters. So now when we click run, you can see that Jenny's height starts out 15 and James's height starts out at 20. And our code now makes a little bit more sense because why should a human have a default height, right? They don't all get created with the same height. And just as we could make the input or the parameter a named parameter in our functions, we can do the same in our class constructor. So we can add a set of curly braces around these inputs to say that when we use it, when we create our new human object, we have to specify that name. So starting height and then a colon. So this way it's a bit easier on the eye and you can see that I'm creating a new human and I'm providing a starting height for that human. As I said earlier, our classes can have properties and it can also have methods. Our methods are simply functions that are defined inside a class. If we were to create a method, let's say, talk, right, to get our little human to say something, we can tell it what to say. So we'll create a string input called what to say. And then inside the talk function, or in this case, the talk method, because we're talking about a function associated with a class, we can say that we'll just print the string that it's told to say. So that means we can tell our new humans, for example, let's get rid of James. Let's just say, Jenny, talk. And the thing that you should say is, why is the sky blue? Now, when we run our code, we print Jenny's height and we get Jenny to talk. And you can see that by calling this method talk, then this object actually performs that action and it prints out the thing that we want it to say into the console. This is now a method that's associated with the human class. And just as we use the dot notation to access the property height, we're also using the dot notation to trigger the talk method. So when we're working with object, you see the dot all over the place, and it just refers to saying, this object, do this, or this object, get me its property. So we now have a pretty simple class, and this class is our blueprint for how a human object should behave and what characteristics it should have. So all of the things that a human object, once it gets created, should be able to do and what it should be. You can, of course, make this as complex as you need it to be, But in essence, we're simply creating a plan for how this object should behave or how it should appear. And we use it by creating it as a new object, and we can create as many of these as we need to and get them to interact with each other or get them to do specific tasks. And so this is how we would create our classes and objects. But why exactly do we need these classes and objects? To find out about that, I'll see you on the next lesson.